Let us prove by mathematical induction that for all positive integer value of n, 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus dot 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 plus 1 by n times n plus 1 is exactly equal to n by n plus 1. We'll do it by principle of mathematical induction that involve 3 steps. First one, we'll frame a statement. Second one, we'll show that this statement is true for n equal to 1. Then we will obtain a cycle so that if it is true for one value of n, then it is true for another value of n, and that cycle will show us that it is true for every value of n. So let's do it. First one, we frame the statement 1 by 1 times 2 etc. equal to n by n plus 1. N is a positive integer. Next, we will show that it is true for n equal to 1. Therefore, P1 is the statement. So we need to start somewhere. So P1 is the statement. What is that? For n equal to 1, you see that 1 by 1 times 1 plus 1. What about the right hand side? 1 by 1 plus 1. You simply replace n by 1. Okay, is this true? That is 1 by 2 equal to 1 by 2, which is true. Which is absolutely true. 1 by 2 is definitely equal to 1 by 2. So we are able to show that this statement is true for at least one value of n, and that is the starting point. So we got the starting point. Now we will obtain a cycle. In order to obtain a cycle, we have to assume something. Once again, if we want to prove something, we have to assume something. So let us assume that Pn is true for some n equal to k. So we are assuming that Pn is true for some n equal to k, positive integer. So once again, if we want to prove something, we need to assume something. So we are assuming that 1 by 1 times 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus dot dot or plus 1 by k times k plus 1 is exactly equal to k by k plus 1 for some positive integer k. Now we want to show that it is true for n equal to k plus 1. Then what will be this expression when n equal to k plus 1? 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus dot 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 plus 1 by k times k plus 1 plus 1 by, replace k by k plus 1. Replace n by k plus 1. So k plus 1 times k plus 1 plus 1 equal to, you see that this much, 1 by 1 into 2 plus 1 by 2 times 3 plus 1 by 3 times 4 plus 2 dot 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 plus 1 by k times k plus 1 by our induction assumption is simply equal to k by k plus 1. K by k plus 1. The other expression we can copy as it is 1 by k plus 1 times k plus 2. Okay, let's simplify this expression. We can take LCM, k plus 1, k plus 2. We can multiply by k plus 2 times k square plus 2k plus 1. Well, k square plus 2k plus 1 can be factorized and can simply be written as k plus 1 whole thing square by k plus 1 times k plus 2. Further, we can cancel k plus 1 out and we will be left out with k plus 1 by k plus 2 can be written as k plus 1 plus 1. What exactly is the right hand side of pk plus 1? We will be replacing n by k plus 1. So k plus 1 by k plus 1 plus 1. K plus 1 by k plus 1. Well, we are getting right hand side of pk plus 1. So what can we say? We can say pk plus 1 is true whenever pk is true. Of course, k has to be 1, 2, 3, 4, etc. If we choose k equal to 1, then we say that if p1 is true, then p2 is true. Then again, if we choose k equal to 2, then we can say if p2 is true, then p3 is true. So in this way, we can say that, so by principle of mathematical Pn is true for n equal to 1, 2, 3, ... As is, Pn is true for every positive integer n. That is, this identity is true.